This is the 4.3 notes. Once we're done with this notes, you guys can go back and fill out the rest of your cheat sheet. I filled out one of those and I posted it under 4.3 on Google Classroom. If you don't have one of those, I put it in the back of the room on the black table. The shelves that are on the right, the black and brown ones, it's labeled on the top left of those. The only thing that's not on there is factor by grouping. I didn't realize that wasn't on there. I think the person that made that was the last teacher, and I don't think he did factor by grouping maybe. So we'll get one on there. However, remember on your quiz that's coming up on Thursday or Friday this week, you get to use your notes. So even if factor by grouping is not on your cheat sheet, you can still use your notes. Use these notes, where that'll be. So today we're finishing up factoring, and we're going to do a couple other factoring methods that are not the same as the trinomial factoring, where we did the x and then the multiply by 30 add up to be 15 and the divide slide bottoms up. These are some that are a little bit different than that. So the first ones we're going to start off with is the greatest common factor. So we're going to factor out a greatest common factor of all these. So the first thing is that this is the first thing you should always look for. Any problem you do, you should see if you can take out a greatest common factor. Sometimes you can, and that'll make it easier. Sometimes you can, and that is the only thing you have to do. The other thing is make sure you're checking when you're done. Make sure you see if you can factor anything else out of your answer. So we'll talk about that in a second. So the first one, between the 6 and the 4, there's a greatest common factor of 2. So 4 divided by 2 is 2. There is no greatest common factor with your variables. So that's just x squared doesn't change. 6 divided by 2 is 3. Now one thing I like about this greatest common factor factoring is it's very easy to check your work. Just distribute like you normally would. 2 times 2x squared is 4x squared. 2 times 3 is 6. That is your answer. So it's pretty straightforward and quick, I guess I should say, to find out what if you got the right answer. So the next one's a little bit more complicated. We have a 12, an 18, and a 6. The biggest thing we can factor out is a 6. Then if you look at your variables, one dead giveaway is that they all have a variable. So we can at least factor out one of those x's. But if you look at the exponents, you can always factor out the lowest exponent. So we can actually take out 2 x's. Now the reason for that is I can take 2 x's out of this one and have 1 left. Out of this one and have 2 left. Take 2 out of this and not have any left. But if you try to take out 3 x's, all of a sudden, if you look at this last one, you can't take 3 away. This one only has 2. So that's why you have to take the lowest amount, because you have to take the same amount out of every one. So different teachers say this differently, but I think the easiest way to think about it is 12 divided by 6 is 2. But then this is the part that I think this is the easiest way to look at it. We have 3 x's with the 12. I'm taking 2 out, so we have 2 left. Negative 18 divided by 6 is negative 3. I had 4 x's. I took 2 of them out, so I have 2 left. I made a mistake. Sorry, this shouldn't be 2. I had 3 x's. I took 2 of them out. I have 1 left. The 18, I had 4. I took 2 out. I have 2 left. And 6 divided by 6 is 1. I had 2 x's. I took both of them out, so I don't have any x's left for that. Now again, you might want to double check to see if you can factor out anything after that. And the main reason I say is because if you thought that you factored out a 2 first instead of a 6, we would have 6x minus 9x squared plus 3. And then if you notice, you can still factor out, I guess I could use a highlighter, from the, okay, maybe not. Sometimes a highlighter works really well, other times not so much. The 6, 9, and 3, we can still factor a 3 out of that. So if we factor out another 3, then 2 times 3 ends up being 6. That's why we ended up doing the 6. So you can do it that way. That's a good way to check your work. It's just a lot quicker if you do the greatest common factor, not just a common factor. So this next one's a little bit tricky. Now I will tell you a heads up, on the quiz and I'm probably on the test, I'll give you a hint with these and I'll say factor completely, not just factor. What I'm hinting at is that you need to factor out more than once on this one. So for this one, you factor out a greatest common factor. So I can take out a 3. That leaves me with x squared plus 6x plus 8. But we are not done yet. We still can factor what's left in here. So now we go ahead and factor like we did before. We're looking for factors of 8 that add up to be 6. If you list all your factors, it's going to be 2 and 4. So x plus 2, x plus 4, and we have a 3 in front. Now, if you factor without factoring out the greatest common factor first, there's two ways it could turn out. It could turn out where you end up with something like 3x plus 6 multiplied by x plus 4. And again, just like number 2, ask yourself, can I factor anything else out? Because in this one, you can factor out a 3. And that's where you get that x plus 2. So that's one way to do it, and there's a couple other variations of that. But the other way, and this is the only thing I've ran into where I don't like the divide, slide, and whatever method, is because if you do that, you end up with factors of 72 that add up to be 18. So that is 6 and 12. So you end up with x plus 6, x plus 12. Then when you divide both of these by 3, you get the x plus 2 and x plus 4. So you do get the right part down here, but you don't get that 3 in there anywhere. So that's the only thing I found, like I said, about the divide, slide, bottoms up method that I don't really like. But it's easy enough, and that doesn't happen enough that I'm not going to worry about it. But again, if you always ask yourself, check for a greatest common factor first, that'll help a lot. Then you don't have to worry about that. So go ahead and pause the video, do these 3 on your own, and then I am going to have the answers on here. So number 4, I kind of have the answer there for you. Number 5, if you take out a 4x to the third, that leaves 3. Now again, we have 5 x's. We took 3 out, so we have 2 left. The next one, we have 3 x's. We took all those x's out, so we don't have any x's left, so I'll have to erase that one. And then the 16, so we had 4 x's. I took 3 of them out, so I have 1 left. Then the last one, I factor out a 2x. We still need to factor what's inside these parentheses. So if you do that, you end up getting x plus 3, x plus 5. 3 times 5 is 15. 3 plus 5 is 8. Again, I encourage you to use our x method if that doesn't make sense to you. So the next thing we're going to go over is factor by grouping. Now I should have renumbered these. This should be tip number 1. This should be number 2. And this should be number 3. So the biggest thing with factor by grouping, the reason I like it, 2 different things. One thing is because this is the one that you use when there's 4 terms. 1, 2, 3, 4. So if you ever have 4 terms, you definitely know you're going to have to use this. I guess I could do greatest common factor, but I don't usually do that with 4 terms. So if you ever see 4 terms, you automatically know exactly what type of factoring you're going to be using. The second thing I will tell you once we get there in the problem. So it's called factor by grouping because we take this and we use one big group. So the biggest first tip, that plus sign right there stays with the 9, and I add my own plus sign. Now, honestly, you don't have to add your own plus sign. It's just if you don't, it looks like it's this multiplied by this, and it's not necessarily true. So I always put the adding sign because I have math PTSD from college. So we have our 2 groups. Each one of those groups, you're taking out a greatest common factor. So the first one will take out an x squared. That leaves me with 3x plus 4. The next one, I can take out a factor of positive 3, which leaves me with 3x minus 4. Now, this is that second reason I really like factor by grouping. In the middle of this problem, there's a self way to check your work. Notice how 3x minus 4 and 3x minus 4 are exactly the same. That has to happen every time. If it doesn't, you got it wrong. So it's a very good way to check your work quick. So the 2 that are not in the parentheses, x squared plus 3 goes together. The 2 that are in parentheses, that are the same, they go together in one parenthesis. So you just have to list it out once. That's how you do this problem. Now let me tell you a little bit of why. Now if this is going to confuse you, or if you start listening to this and it gets confusing, you can totally skip over this because you don't need to know this. For some of you, it might help. How do I go from this step to this step? How does that make sense? Well, in this step right here, if you multiply this, you would take x squared times 3x, then the x squared times negative 4, then 3 times 3x, and 3 times negative 4. Well, isn't that the same thing down here, where it's x squared times 3x, just like that yellow one, x squared times negative 4, just like the yellow. 3 times 3x, 3 times negative 4, just like that yellow. So that's how we get that answer, or that's why we can go from one to the other, provided that they are both 3x minus 4. So the next one's where you're actually going to use tip number 2. So tip number 2, when you draw this, first off, again, make sure that sign stays with the 30. If it's a plus like that last one, it's not really as important, but I always tell you guys to do that because if it's a minus, it's definitely important. So if that second group starts with a negative, so they're talking about that negative right here with a 30, that means you want to factor out a negative number. So that doesn't really affect my first one. I factor out a 2x squared, which leaves me with 6x plus 1. But now, instead of factoring out a 5, I want to factor out a negative 5. If you don't do that, it's going to mess things up. So it leaves you positive 6x plus 1. Now, those are both the same. If you were to factor out a positive 5, the only difference is you'd have negative 6x minus 1, so you're really close. So you can go back and change some signs. Factor out a negative. That changes these signs, then you're in business. So again, hopefully, if you mess that up, hopefully you catch yourself. So 2x squared minus 5. It doesn't necessarily have to go first. It doesn't matter which order you put these binomials in. But then 6x plus 1 last. And the last one, put your groups. I can factor out an 8x squared. That leaves x minus 8. Now, for this one, if you can't factor out anything, please factor out a 1. That doesn't happen usually, but for our purposes, that's definitely going to help you with this one. So you factor out a positive 1. That leaves you with x minus 8. Now you can see those are the same like we wanted, x minus 8, x minus 8. So we're left with x squared plus 1 times x minus 8. Now, again, go ahead and pause these questions quick. And these are the type of questions that are not on your cheat sheet. Again, I'll probably put one on there. It's probably going to be one straight from the notes. I might put a couple on there just to make sure we have these different types. But go ahead and pause, then do these on your own, then check your answers. I'm going to go ahead and put the answers up here quick. If you aren't sure how I got the answers, number 10 is exactly like that one that's right above it. Number 10 is like number 7, number 11 is like number 8, and number 12 is exactly like number 9. So if you have problems, go ahead and refer back to those. All right, so these are the answers to number 10, 11, and 12. Again, if you want to pause so you can see my work, you totally can. And again, if you need help on any of those, if you don't know how I got the answer, refer back to those ones right above it. Like I said, that's how you do those 3, the exact different numbers, obviously, but the same steps. So the next thing we're going to look at is difference in squares. Now, the biggest thing is these are all binomials. Now, unlike the last ones where there's 4 terms, sometimes binomials you'll do different ways. So you definitely have to be careful. It's not that every time it's a binomial you do difference in squares. But it's called difference in squares for a reason. It's got to be subtraction, and those two have to be perfect squares. So there's a couple different ways that I've tried to teach this. One method is I draw little brackets or little tree diagrams, and I say what number times itself is x squared, what number times itself is 25. The only problem is when I used to do that, some people with like 36 would be 4 and 9. And again, it's got to be the same number. So if you do that method, I like that method. You've got to make sure it's the same number. So I'll probably say that same thing, what number times itself, but I've started doing it this way, where what number squared is x squared, what number squared is 25. So x squared is x squared, 5 squared is 25. So once you have the x and the 5, all you need to do is do x plus 5 in one parenthesis, x minus 5 in the other parenthesis. Now, one other way to do this that takes a little bit longer, but if you want to double check your work or if you just like it better, it doesn't work for some of these more complicated ones, but really x squared minus 25 is x squared plus 0x minus 25. So I'm looking for factors of negative 25 that add up to be 0. Well, it's got to be positive 5 and negative 5. They multiply to be negative 25, they add up to be 0, so that is where we get that answer. So that's just another way to look at it. But again, that gets a little bit more difficult with problems like number 14. So what are two numbers that multiply to be 49w squared? Two numbers that multiply to be 36t to the sixth. So 7 times 7, what number times itself is 49? W times w is w squared. 6 times 6 is 36, but what about t to the sixth? Well, t to the sixth, a lot of people say that's not a perfect square, but the thing is, it is because it's an exponent. So the easiest thing is, if it's an even exponent, you just divide it by 2. If it's an odd exponent, it's not a perfect square. We can't do anything. Now, if you remember, and this is just a side note, if you remember from Algebra 1, we had some exponent properties. If we have t to the third multiplied by t to the third, we add those exponents. So that's one way you can look at it. What number times itself is t to the sixth. The other way to look at it is if you had the property t to the third squared, you multiply those exponents, which again gives you t to the sixth. So either one works. So just like the last one, we end up with 7w plus 6t to the third, 7w minus 6t to the third. I know that t looks a little bit sloppy. And the last one, we have x squared plus 16. A lot of people get fooled by this. This is a perfect square. This is a perfect square, but it is not subtraction, so you cannot factor. So technically, you could say this is prime. You can't factor it. Or if you just put can't factor, that's fine. You will not have one like this on your test or your quiz. I maybe will put one on the test that's multiple choice, where it says, like, which one can't factor or something like that. Yeah, again, just make sure you're double checking. It's got to be two perfect squares, just like this one, but it's got to be subtraction. So again, go ahead and do these on your own. I'm going to go ahead and put my work and the answers up there for you to check. So go ahead and pause it, then unpause for your answers. So these are my two answers. It doesn't make any difference what order it goes in. This first one, you could have put x minus 9 first and then x plus 9. Doesn't make any difference on that. So now the last thing we're doing is solving with factoring. Now, I will tell you this first part. If you don't want to look at this, it's up to you. Again, this is one of those things that I don't want to confuse anybody, but for some of you, if I tell you why we're doing it this way, I think it helps you remember a little bit. So this is one thing we call the zero product property, which you guys already know this property. It's your favorite one. It has been since like 2nd or 3rd grade, whenever you remember multiplication. Anything times 0 is 0. So 0 times x, it doesn't matter what the x is. It could be 10. Who cares? It's 0, no matter what. This is how we're going to use it more today. 0 multiplied this binomial. Again, that binomial, you could plug in 10 or 100 or 5 or negative 100, doesn't matter, because 0 times any number has got to be 0. That's the zero product property. So what that means is, as long as we can get these equal to be 0, we can use this to solve. So this is the first baby step. These are kind of already factored for you. And I'll talk about this tip here in a second. So if I can make this parentheses equal to 0, then it doesn't matter what these parentheses are. We'd get 0, and vice versa. So that's what we're going to do first. So what could we do? What would we plug in for x to get x minus 6 is equal to 0? If you don't know, you can solve. Subtract 6, we get x is equal to negative 6. If you plug negative 6 in there, negative 6 plus 6 is 0, so we're good. And again, you can double check. If you actually plug negative 6 in there, you get negative 6 plus 6 is 0. Negative 6 minus 10 is negative 16. Is that equal to 0? Yes, because it doesn't matter that 16. 0 times anything. So same thing with this. X minus 10 is equal to 0. So you add 10 to both sides. You get x is equal to positive 10. Those are your two answers. And for almost all these, you will get two answers. So this is what I'm talking about with this step over here. A lot of students start noticing this, and they start taking a shortcut where all they do is they just skip to the answer. And they say, well, it's the opposite. If this is plus 6, then the answer is negative 6. If it's negative 10, the answer is plus 10. Now, here's the deal. I don't mind if people do that, and I don't mind if you notice that, except for how do you do this one? Because it's not negative 3 and positive 3. It's a lot different because we have those numbers in front. So instead, I'm okay with that shortcut, but instead of saying what makes this what's the opposite of this, I always say, what would you sub in to make this 0? Well, if it's positive 6, if you're adding 6, then we're going to plug in a negative 6. What would you plug in to make this 0? Well, you'd plug in a positive 10. Since it's 10 minus 10, that would give you 0. So the reason is, again, for these, most of you guys shouldn't and can't do this in your head. So we have 2x plus 3 is equal to 0. So I would just show your work and do it long way. Subtract 3. 2x is equal to negative 3. Divide by 2. We get x is equal to negative 3 over 2, which is fine. And for this one, we have 5x minus 2 is equal to 0. We add 2 to both sides. Divide both sides by 5. We get x is equal to 2 over 5. Again, these fractions are a little bit more difficult, but if you plug them in, you'll see that one of those parentheses will end up being 0, and so the whole thing is 0. Now, one of the keys to this is that it's got to equal to 0 first. So number 21, we've got to work with that a little bit to get 0 on that right-hand side. So we're going to do the same thing we just did, except for now we're going to do the factoring part. And honestly, in my opinion, I think that's the hardest part, because it kind of depends on how good you are at factoring and what the problem is. So factors of 24 that add up to be negative 10. If you need to list your factors of 24, go ahead and do so. The ones that are going to be negative 10, almost 4 and 6, but remember, that's going to be positive 10, so we need to change both of them to negative. Negative 4, negative 6. Double check. That does multiply to be positive 24, does add up to be negative 10. So we end up with x minus 4, x minus 6 is equal to 0. A lot of people miss this because they stop there. Remember, we're solving this, so what would make this first part 0? Positive 4. Positive 4 minus 4. What would make this part 0? Positive 6. Now, some students get confused. How do I know when I'm factoring or when I'm solving? Well, first step is it tells you solve up here. I know you can't see it right now, but you're solving by factoring, so that's when you solve. Second dead giveaway is it's got to be equal to something to solve. If you go back and look at ones we did before, none of these have an equal sign to them. Not any of them today, not any of them last 4.2, not any of them 4.1. None of them have equal signs. So the next one, this is the one that's the most work because there ends up being a leading coefficient, which is fine. When you get it equal to 0, make sure you combine your like terms. So I'm looking for factors of 6 that add up to be negative 5. Now this is an interesting one because make sure you're using the correct numbers for this. I've seen people use 1 and 6 a lot. You've got to make sure you realize it's negative 2, negative 3. They multiply to be positive 6, add up to be negative 5. And again, the way you check is check your signs if it's 1 and 6. So we end up with x minus 2, x minus 3. Again, you don't have to do that, but I like to remind myself that it's equal to 0. Then we put the 3 in the denominator here. So we have 3x minus 2, x minus 1. Then from here we solve this. And again, this is where a lot of people accidentally just circle it because they forget that they're solving since it took them so long to factor. So this 3x minus 2 is equal to 0. I know we don't have a lot of room for this. I'm just going to squeeze it in here. Actually, I'll just do this. 3x minus 2 is equal to 0. So add 2. 3x is equal to 2. Divide both sides by 3. Whoops. So you get 2/3 for that. And then this one, just x is equal to positive 1. That is your answer. Now the last ones aren't as bad. This one is factor difference in squares. There's actually some other ways to solve this one, but we're going to stick with difference in squares. So what number squared is 4x squared? That's 2x. What number squared is 81? Is 9. So we have 2x plus 9. Whoops. And 2x minus 9. So the good news is one's positive, one's negative. So once we solve one, we pretty much solved the other. 2x plus 9 is equal to 0. Subtract 9 from both sides. You get 2x is equal to negative 9. If you want to leave this as a fraction, you can. Negative 9 over 2. Or we can reduce it down to negative 4.5. Doesn't make any difference to me. And then again, we know that this one, the only difference is it's a negative, so it's just the sign is going to be the opposite for our answer. And last one, this is a greatest common factor, so I'll take out a 2x. That leaves x plus 3. Now, for whatever reason, this is one that a lot of people struggle with. And the reason, I guess I should say, I think I know the reason. The first, or the parentheses are easy. A lot of people get that part as negative 3. But then they don't know what to do with this one. They don't know, is it negative 2? Is it 1/2? What is it going to be? Sometimes if I put in parentheses, it makes it easier for students. But just like before, what would plug into x to make this 0? Well, it's 2 times x, so it's 2 times 0. 2 times 0 is 0. So you can go ahead and use this to fill out your cheat sheet. Again, there's already one filled out that's on Google Classroom. If you have any questions, make sure you're letting me know. And again, we will have our quiz next time I see you guys on Thursday, Friday.